Okay, Epic Gamers, today we're gonna do some category theory actually. Surprise, surprise. I'll have a meetup soon and I need to prepare a presentation basically. Do this. I think I already at some point made a beginning for this. I need to look at that. But for now we can just get started with reading the blog post, I think. I need to read it anyway. This is actually, should be quite easy because it's talking about ADTs. Should be quite easy in that we use ADTs extensively in Haskell. It sounds pretty impressive, you know. Generic, no, not generic, what am I talking about? Just algebraic data types, right? It sounds pretty impressive, but in fact it's actually simple. It's there are only two. There's the sum and the product. And everyone should be kind of familiar with products already because you would use them in any programming language basically. If you have a class, you could say, for example, the fields are the product of your data type. What's up, Skybro? How you doing, man? Were you expecting something else or something? Hi. No, I need to prepare this presentation. I should have prepared this yesterday, but I keep postponing it because I don't know. Yeah. Category theory for programmers. ADTs. That's the thing we want to look for because there's a blog post about that. No, I just joined. Okay. Yeah, so we need to make a presentation, category theory for programmers. Because I'll have a meetup about that tomorrow in Amsterdam. And I need to present actually. I need to present. So I want to just, you know, make that presentation now. It's this blog post. This one. And they're basically explaining how tuples work. They're literally explaining how tuples work. Not in Karlstad, Sweden? No, not in Karlstad, Sweden. I don't even know where it is. Yeah. So we can explain tuples through morphisms, and if we do that, then we gain a category, I think, or something. I don't know. I think you need to explain everything through morphisms. What they're doing here as well. So actually, I think I streamed this as well, the products and co-products post. It's like maybe on YouTube, maybe. Yeah, before I had the editing program. Link? Oh, sorry, yeah, sorry. Not the products and co-products, the other one. There you go. Quiet down you a little bit. Excellent. So let's just read this thing and then after reading it we'll make the presentation. And then we're done. It should be like an hour or two? Who knows? So, here, assumed you read the other parts, but we can skip that, that's fine. Like, actually, this thing is structured kind of weirdly because they introduced Claisley errors before Claisley categories before the ADTs. So this is actually quite a simple topic, right? Because, you know, you have sums and you have products, that's it. But no, we will introduce monads before doing ADTs. I read this book, a bit too much C++ for my taste. I think you're lucky because he's mostly skipping the C++ here. I think what he tried to do is like, okay, I want to make this accessible for all programmers. What do all programmers know? C++. Let's write all the examples in C++. We're not going to do that. In a presentation, we're going to make it in Scala. Because, you know, all programmers know Scala at this point. That's legitimate. But yeah, this is all Haskell, actually. He's like completely skipping on the C++ part. Oh, no, he's introducing it later. Okay. How long is it? It's pretty long. Okay, let's start then. Scala, whoa. I know a little bit of Scala. I've done it when I was younger. That's why I almost settled out on it. But I failed. We've seen two basic ways of combining types, using a product and a co-product. It turns out that a lot of data structures in everyday programming can be built using just these two mechanisms. Not a lot of data structures, all data structures. This fact has important practical consequences. Many properties of data structures are composable. For instance, if you know how to compare values of basic types for equality, and you know how to generalize these comparisons to product and co-product types, you can automate the derivation of equality operations for composite types. And we see this in Haskell with the deriving mechanic, right? We do it all the time in for example, my project. Like, I'm deriving JSON stuff, I'm deriving all kinds of shit. Let's see. Well, that's a bad one. Let's go to entry, yeah. So he's talking about this stuff. And it's like, okay, we can just figure out how to do equality on these things because it's a self-occurring type. That's what he's talking about here. But if I would do it now, sleep. I'll shut up then. Like, we'll continue with category theory. That's the one I saw. It's the cool one. You use the lenses. But, you know, it was like a fair comment on this. This doesn't feel nicely. So I told them on Reddit, like, hey, you should use fading. That's the one I saw when I woke up. When you woke up. You know, just a regular time, like 2, 3 p.m. That's just normal, right? Just before the sun sets. Check Reddit when I wake up. Yeah, I did something similar. Maybe I get directed to One Piece though, so not always. I mean, I used to. Mechanical implementation of a product, 2 types. Oh right, we already read this. Okay. We're making some progress, guys. We need to go until here, about here. We can make it. You know what? Another good one is the morning paper to check out. But I don't. I should do that more often. There's this website. The guy is actually just making a summary of papers. Most of the time, not every day, but morning paper. If you wanna get some impressive jargon, you can use this. Firefox is rebellious. This one. Let's not read that right now. I used to do it before, but this is the reference I'm making. Let's see what it is. Nani? Oh, you're making her. Huh? I didn't see that. My Sundays are dedicated to hibernation. That's a good way to spend your Sundays. Okay, let's see. Where are we? You can think of 2 pairs as simply using a different format for storing the same data. Just like a big endian versus little endian. Just like big endian versus little endian. Oh, I know, you guys are all familiar with this concept, right? Endian. Big endian. Zook, yes. Oh my god, you actually are. What's up, Zook? How are you doing, man? What happened? Endianness. Computing endianness may refer to the order of bytes, or some bits within a binary representation of a number. It can also be used for more generally to refer to the system. A big endian ordering places the most significant bytes first and the least significant byte last. Okay, so it means like if you go from left to right with like 1s and 0s, then big endian would mean you put more value on this thing, and little endian means you put more value on this thing, and then a little bit less value on this thing, and etc. Great. Everyone knows that apparently. Except me. You can combine an arbitrary number of types into a product by nesting pairs inside pairs. So this is how you can make a list exactly out of pairs. You can just keep on nesting. You know, you have like a first element, and then you do like second, and then you do like third, and you do like third, fourth, etc. Right? This is how lists work in real life. But it's an easier way. Nested pairs are equivalent to tuples. Lisp. So let's vote for Yappy doing day 1 of AOC. But I need to finish this! Like, I got into trouble if I don't finish this. No vote. This is a dictatorship. I don't know. Yappy land. I don't know. Age of Empires? Age of Conquerors? It's like, oh, that's 7. I'm not sure if I like this. I think you guys are rebellious. I think I need to punish you guys. You know what's gonna happen now, right? You know what I made for you. I knew this would happen at some point, and I prepared for this. Fuck yeah. There you have it, guys. You did it to yourself. No longer rebellion. This is a dictatorship, sweetheart. And if I move it, you can combine an arbitrary number of types in product by nesting pairs. There's an easier way. Nested pairs. You know what the fun thing is? I can even close this, and they will still remain around because I disowned them. I disowned them. There's no way to get rid of them. We'll keep moving. It's a consequence of the fact that different ways of nesting pairs are isomorphic. If you want to do a combination of 3 types in a product ABC in this order, you can do it in 2 ways. A, B, C, or yeah, okay, that's cool. That's cool. Bring the Haskell, man. These types are different. You can pass one function with easy consequence of the Yoneda Lambda. Okay, of course the Yoneda Lambda. Okay. Thanks for helping us understand this stuff. Like I just couldn't bridge that gap between nesting of pairs and Yoneda lemmas. If you want to combine 3 types in a product, A, B, and C in this order, you can do it in 2 ways: A, B, C, or A, B, C. Yes, that's how you read that, by the way. That's the proper pronunciation. So it's A, B, C, or A, B, C. Exactly. I think I did it differently the second time, but whatever. These types are a bit different. You can't pass on to a function that expects the other, but their elements are in one-to-one correspondence. There is a function that maps one to another. This is just swap, right? Yeah, it's easy once you see it. Yes. Once you see it. You should stop looking at the cats and just see it. But, maybe you should kill the cats. I don't know. It's isomorphic to A. So you can always introduce a unit to a type. I don't know what you're showing off here, but you can do that. So in fact, any type is just a set of infinite units attached to them, because you can always imagine one. Yes. These observations can be formalized by saying that set, the category of sets, is a monoidal category. Oh, it is a monoidal category. It's the category that's also a monoid, in the sense that you can multiply objects. Hallo? Nou. Oké. Wacht even. Kom maar zo. Yeah. I need to do some manual math. I need to go on a break for like 10 minutes. I'm sorry. I'm being distracted by... Yes, I need to go on a break. I'm sorry. Robbed? Yeah, sort of robbed. Exactly. I need to babysit yeah. I need to manage some things. I need to put down some fires, basically. I'll be back in 10 minutes, I think. I'll be right back. I'm sorry. Not end. We'll do start and we'll show the break. Be right back, like 10 minutes. Oh my god. Oh my god. That just happened. So, yeah, I basically need to pay out some people. I'm like babysitting the company and yeah, they ask for money, so I need to pay them out and do all the calculations and whatever. But we are back. We are back. Let's see. What was I doing? He got swatted already. Hope you. He had to babysit someone. Small break. Yeah, I had to babysit the company. I'm sorry. So to the first line is the type declaration. It uses the type constructor pair with string and bool replacing A and B in the generic definition of pair. Okay, it's explaining that what I just said. Okay. Type constructors are used to construct types. Data constructors want to construct values. Since the namespace for type and data constructors are separate in Haskell, you would often see the name used for both, as in pair. Okay. Okay, so he was using P to make it obvious that they're actually different. Even field built-in pair type as a variation of the kind of declaration, where the name pair is replaced with the binary operation. Blah. Okay, this is how you can use tuples. Similarly, you can use break triples and so on. This is a weird way of constructing a tuple, but there you go. I didn't know that worked. I thought you need sections for this. I think you need tuple sections for this. Instead of using generic pairs or tuples, you can also define specific named product types, as in, which is just a product of string and bool. This is like the more like this doesn't have any type variables. He's explaining this stuff like really strange. He's going from the most general cases to more obvious explicit cases. It's so weird. Because like I would introduce type variables much later on. Just started with this stuff. Which is just a product of string and bool. So you can never change the type of these things. They're always string and bool. But given your own name and constructor. and read the book backwards. Is it intended like that or something? Would you start with the Uneta embedding, right? Monads, category, larvae theories. I don't think so. Topoi. Khan extensions. Wait, so who did you read this book, Sour, or who did read this? Maybe Skybro did. Yeah. Oh wow. So did you like understand everything? Do you know what a Khan extension is? Do you know what the left Khan extension is and the right Khan extension? Hands and comments. No. Okay. So how much did you get? Did you get to Uneta embedding? Did you like do that lifting stuff with const? I've kind of seen somewhere at some point. Because, you know, here, this is at this point I'm losing my little Haskell edge. And I need to actually, you know, read it very carefully to understand what the fuck's going on. This book was, I already know this stuff, or I still won't get this stuff. Yes, that's what I'm saying. Like, I'm gonna lose my little Haskell edge at some point, and then nothing will make sense anymore. Because even the Haskell stuff, I don't think it's a great way of explaining it. I mean, it's all correct. Sure. But it wouldn't start like that. Maybe you need to read those, like, paragraphs backwards. Because it didn't did enough Haskell before reading it. Yeah, so I probably will have the same problem then. Later chapters would have conveyed much more meaning if I'd known lenses. Confusion helps you? Does confusion help? Okay, so like if you add confusion to this book, then everything will make sense. Of course. Instead of using generic pairs or tuples, you can also define specifically named product types, as in data statement string. Oh right, we already read that. Which is just a product of string and bool. But it's just given its own name and constructor. The advantage of this style of declaration is that you may define many types that have the same content but name different meaning and functionality, which cannot be substituted for each other. Programming with tuples and multi-argument constructors can get messy and error-prone. Keeping track of which component represents what is often preferable to give names to the components. A product with named fields is called in Haskell, a record in Haskell, and a struct in C. He's actually explaining... yeah. Start with symbol. He's directly diving into that, huh? I don't like this. I had a little project I started at some point. Let's see. Getters and setters in Haskell. This is what records do. They generate these functions for you. So you pattern match on person to get out like the string, right? And if you want to set it, you just, you know, pattern match on it and you replace it with the rest. Set name. Get and set. This is like the beginning of getting into lenses as well. And then like the next phase is you would add like records, right? You would do name and age. And now you can set it like this. Set age. Set age prime. Set name prime, I guess. X. This is all just syntax. Because we already could do this before, right? That age. The compiler will figure this out for you. This stuff. But this is all what's happening under the hood. It's the only way of doing it, basically. So it has to do that. Okay, cool. Let's have a look at the simple example. We want to describe the chemical... But I think we want to describe the chemical elements by combining two strings, name and symbol. And then we want to integer the atomic number into the data structure. We can use a tuple string int. And remember which component represents what. We could extract the components by pattern matching, as the function that checks the symbol of the element is prefix of its name. HE as an idiom. Starts with symbol, blah. That's like the function for that. This code is error prone and hard to read and maintain. Much better to define a record. So this is what you're doing here, like that stuff. The two representations are isomorphic as witnessed by the two conversion functions which inverse over each other. Wow. So like, you know, with monoid you have that law, right? If you combine it with a mempty, which would be void, it doesn't make sense to do it in any case. It doesn't make sense. You should just do this. Okay, cool. We figured that part out. We figured one sentence out. Next, on to the next one. Charge. Construct on the left construct, and they are, or we skipped a bit. In terms of types, we have either monadic category and void. Inhabited type, as it is a neutral element. You can think of either as plus and void as 0. Yes, he's saying that here, like the plus thing will do nothing. If you combine an either with void, nothing will happen. Indeed, adding void to a sum type doesn't change its content. For instance, yes, so you're saying it again. Why are you repeating yourself? It's because there is no way to construct a right version of this type. There is the value of type void. The only inhabitants of the either void are constructed using the left construct, and they are simply encapsulated by the value of type A. So symbolically, it's A. So that's what I'm saying right here. You can just get rid of the entire either if you have the occurrence of that. If you have this being occurred, you know for a fact that it's always A, because you can't have void. It doesn't exist. It does exist if you include bottom type, but let's not talk about that. We don't talk about that. We're Haskell programmers, we only care about perfection, and we just ignore the fact that bottoms exist. That's what we do. Some types are pretty common in Haskell, but their C++ equivalents, unions, or variants are much less common. There are several reasons for that. First of all, the simplest sum types are just enumerations and are implemented using enum in C++. The equivalent of the Haskell sum type red, green, blue is the C++ enum red, blah blah blah. An even simpler sum type, true, false, is a primitive bool in C++. It's not even a bool, it's a fucking int. But int is also a sum type. I just want to point it out. Int is a sum type. You always have a value of int, but you don't, like, you know, you can't have 4 and 5. You can, but it's complicated, okay? It's a sum type. I'm just like realizing how weird int is. Integers are. You can also have operations of integers, and they point to themselves. They're endomorphisms. You're recording that, chat. Are you listening? You're paying attention. I'm having realizations here of a lifetime, maybe. Like empty strings, negative numbers, null pointers, etc. This kind of optionality, if the deliberate is expressed in Haskell using the maybe type, it may be A, nothing just A. The maybe type is a sum of two types. You can see this in separate two constructors into individual types. The first one would look like this. Data nothing type is equal to nothing. It's an enumeration with one value called nothing. In other words, it's the singleton, just the equivalent times unit. The second part, just type just. Okay, I think I actually did this on the, I showed them this during the last meetup, which was like a couple of months ago. Maybe they forgot about this. But you can represent a maybe into an either with unit. More complex sum types are often. It's kind of funny because I think a lot of people get into functional programming and they run into this maybe thing. And like, you know, people are saying that, oh, that's a pretty awesome thing. You can use a maybe and then you don't have to check as much on if something is nothing or not. But when I first started with this, I just found it annoying as fuck. It isn't until you start using it like a monad that actually makes sense. But let's not digress into that. Still live? Okay. More complex sum types are often faked in C++ using pointers. A pointer can be either null, oh that's actually clever, or point to a value of a specific type. For instance, a Haskell list type, which can be defined as recursive sum type, can be translated into C++ using the null pointer trick to implement the empty list. Yes, that's clever, I guess. You just have so much cons. They're using cons as well. Oh, okay. Just A, and it can be null either null or next one, and then this may be nil. So it actually looks like a nested tuple, like I just showed before. List is 1, 3, no, 3, 4, and then at some point you end with like unit, because the nil is then the unit, and then you have items in the list. So weird. Now the two Haskell type constructors nil and cons are translated into. Actually, come to think of it, no, this is a more weak type signature because this can change types, this structure, and this guarantees that the list will always be of the same type. Weird. Where's music? Oh, you've. Notice that the two Haskell constructors nil and cons are translated into two overloaded list constructors with a nebulous argument, none for nil, and the value of a list for cons. The list class doesn't need a tag to distinguish between the components of the sum type. Instead, it uses a special null pointer value for head to encode nil. Oh, this is talking about C++ stuff, right? So in C++ you would just check for null pointers everywhere. And you kind of do the same thing in Haskell, except we, formalize it with nil. The main difference, though, between Haskell and C++ types is that Haskell data structures are immutable. If you create an object using one particular constructor, the object will forever remember which constructor was used and what arguments were passed into it. Yeah. So immutable doesn't mean that you can't change values. You can keep on creating new things. That actually crashes. We see the 4 though. But this still worked, this part of the program. But if you go to the entire thing, it doesn't work. I can show it working by deleting that thing. Because of laziness, basically. It works. This never gets evaluated. Why am I showing these examples? It's like always trying to find a way of, making the auto lie. But we don't speak about bottom type, so yeah, this is taboo. Another thing that links addition and multiplication is the distributive property, B plus C. Does it also hold for product sum types? Yes, it does, up to isomorphism, as usual. The left and right correspond to the type of A, either B, C. And the right hand side... Oh wow. Yeah, because you can just take this value and do bimap. Doesn't hold for linear types though, they will be different. But in Haskell we don't have linear types, so it's legit. Here's the function that converts them. I wonder if like this must change if you introduce linear types. This category stuff for tuples and whatever. I think the rules change. He's just using bimap, yeah. He's using bimaps in many words. And the other way goes round. Okay, excellent. The case of statements is used for pattern matching inside the function. Actually, you choose in this case, right? No, you don't need to because it's okay. The case of statements is used for pattern matching inside a function. Each pattern is followed by... Okay, it's explain case. I'm not going to prove that these two functions are inverses of each other. But if you think about it, they must be. This is like proving by coercion, basically. But it's pretty obvious. They are just trivially repacking the contents of the structures. It's the same data, only different format. Like he's continuing with coercion, excellent. Best way of proving things, right? Mathematicians have a name for such two inverted monoids. It's called a semi-ring. Intertwined monoids, it's called a semi-ring. It's not a full ring because we can't define subtraction of types. What are the two intertwined monoids? Are we talking about products and co-products, or are we talking about the correspondence between sums in like types as sums are with the analogy we made? What are we talking about, man? Because we can't define subtraction of types. Sum. Master boot record Doom 2. I'm sorry, like DevTrack died, so we can't use the sum command anymore. It's a master boot record Doom 2. There you go. Am I talking? Yeah, okay, cool. Mathematicians have a name for such two intertwined monoids. It's called a semi-ring. We don't know which two intertwined monoids, but I think we're talking about products and co-products. It's not a full ring because we can't define subtraction of types. That's why a semi-ring is sometimes called a rig, which is a pun for ring without an N. Negative. Oh my god. It's a really bad pun. So what do you get if you remove the N from ring? You would get a rig. That's the joke. I'm explaining jokes. That's how far we descended into madness. Yeah. Cool. But barring that, we can get a lot of values from the translating statements about, say, how are you doing? By the way, doing Andrew from Narsel? I haven't seen you in a while. Andrew from Narsel, which is from a rig. Statements about times. Here's a translation table with some entries of interest. Right. A plus B. So we're just showing their numbers are the intertwined monoids. It's a rig because you don't have negatives. Is it like this definition is only about numbers? I'm just gonna Google it. I don't know what he's talking about. In abstract algebra, a semi-ring is an algebraic structure similar to a ring, but without the requirement that each element must have additive inverse. The term rig is also used occasionally. This originated as a joke, suggesting that rigs are rings without negative elements. Aha, again. It must be very important to I like how it became a norm. Semi-ring is a set of R equipped with two binary operations, plus and product. Okay, so we're actually talking about if you have something that has a plus and a product, then you are a semi-ring, satisfying these laws. So numbers are a semi-ring because we can, you know, do addition with numbers. Doesn't need to define a 0, I guess. It's a commutative monoid with the identity element 0. It's a monoid with the identity element 1. It doesn't commute! It does either commute. Been good, I've been on stream other times. Usually just lurking though. Oh, cool. Gotta have that song though. Yeah. It's a good song. It's a good song. Multiplication left and right distributes over addition. Multiplication by 0 annihilates R. Truthy. What's that mean? I'm an idiot. I can't program apparently. No truthy. Yes, truthy. I think it's yes though. She got them both. Oh, need to run. So -1 on truthy as well. There you go. Doesn't map that good then, I guess. This analogy goes deeper. The basics of Curry-Howard isomorphism between logic and type theory. Is the base of Curry-Howard isomorphism between logic and type theory. We'll come back on this when we talk about function types. Show the isomorphism between maybe A and either unit A. So this is just making a function from maybe A to either. This is trivial, I think. You can just quickly do that, I guess. Do I have my talk thing? Category, huh? Challengers. Haskell. Oh, this is org mode. And sure, yeah, org mode is a pain for programming. But you can show the isomorphism between maybe and B. So we need to do from maybe A to either A, right? So just do from just X is equal to right X. And in the other case, nothing. We'll do left nothing. And then you can also do 2, I guess. There you go. In case of right, you're just X. And in case of left, you're just nothing. Okay, there you go, isomorphism. Here is a sum type defined in Haskell. Circle float, rect float, float. When you want to define a function like area that acts on a shape, we do it by pattern matching on the constructors. Implement shape C++ or Java as interface. Create. I'm not gonna do that. Java as an interface and create the 2 classes, circle and rect. Implement the area as a virtual function. Oh, it's actually pretty trivial in Java, I guess. C++ is so much writing. I don't want to do that. Area Java. I mean, this is trivial, right? Do we really need to do this? Does it help anyone? You do like interface, area 8. I don't even know how to write valid Java. You just do like get area. No, it's not like this. No, not arrow either. It's, oh right, int. This. And then you do like class, circle, extends, area. Nowhere. And then just to get area. Public. Add override. I know things. I know how to write Java. Circle. I guess you have like a radius, right? It's public final int. Public final int. Return. Yeah, we're doing beautiful Java. Like, this is how far we have come. They're telling me to use Java. That's become of this stream. Yes. Like, there's no Scala option. Or, well, like, that's better, but I don't know. Clown Fiesta. It's a we call it DNH, right? Did you saw how powerful my copy-paste function was for Java? I just copied this entire class, and then it was so easy to implement. I don't think this is done, right? This is legit. Oh no, it should be implements, I think. Implements. Can I compile this? Let's try running it. Yes. No archival function for Java. Clown Fiesta. Yeah. I'm slowly becoming a coding clown. I think I want to put it on my resume. Professional coding clown. I come to the office and make your entire engineering staff laugh at madness. I want to develop in JVM, at least use ETA. What the fuck's ETA? Language? No. Can't sell this, man. This is just Haskell on the JVM. It uses servant? You're bringing me ideas, man. Oh, they don't have their builds. Oh well. We're doing the continue with the previous example. We can easily add a new function circ that calculates the circumference of a shape. We can do this without touching the definition of shape. What is a shape? Add circ to your C++ or Java implementation. What parts of the original code did you have to touch? Are you a pervert? We're not allowed to use ETA. We're only allowed to either use Java or C++. Like, I'm a normal programmer. I don't know any better languages. I just know C++ or Java. That's category theory for programmers, not for crazy. Yeah, I don't know why. I mean, I guess back then everyone was using that or something. I have no. It's from 2015. Okay, it's a long time ago. For clowns, yes. Category theory for clowns. How's your day, Subs? How are you doing? What brings you to this stream? Oh, you already said. Good for the Ahsoka. Epic. Hunter x Hunter. Best anime. I like Ahsoka is one of my favorite characters in any case. I love him. He's so passionate. And I like Haskell. Excellent. Hunter x Hunter plus Haskell. Chasing your dreams, huh? It's like an epic treasure on the end of a quest. Yeah, so we need to go from, I guess, and then to, and then we have shown the equivalence, or something. We also need to say that this is the same as that. Show that a plus a equal to 2. Maybe we need to do it step by step. We need to first look up plus, and then we need to look up what a product is. And then we also need to look up 2. But I already did that. 2 is a number, 1, which is truth, in C++ at least. So we can go to true and then say, okay, we have a unit. I don't know. Do I need to do this explicitly? What do you think, Subness? 2. I'm really novice at Haskell. This is not Haskell though, this is category theory. This is completely different. This is basically theory. So, you know, no compilers. I'm just like more not asking. I'm just asking, how should I answer this? Should I actually show it step by step, or should I just say this is it? I'm not sure. I'm legitimately not sure. What is your opinion? Maybe we should do that then, step by step, huh? So we need to look up plus, which is either. Okay. Lookup plus, which is either. Oh yeah, that's actually a good idea. You can ask Skybro for help and guidance. Advent of code. A lot of people use this to learn new languages and code. Just try out things, because this is just a daily challenge of like 10 minutes per day. And you can just like solve this, right? Not that long. And Skybro will be happy to help you. Or you can also ask in stream, by the way, or on Discord. If you run into anything, feel actually free to ask. I want to say Skybro, but no, it's fine. Just to do it in general, I guess. Yeah. So this is like a really good way to just learn a new language. It will throw challenges at you, and we have a community to help you. Yes. Excellent. So we need to look up plus, which is either that, and then we need to look up 2, which is number 1, which corresponds to true in logic, which is, yeah, no worries. It's actually a really good idea. Okay, so we looked up 2, and now we need to look up product. Star, which is A, B. And then, you know, you just put in the 2 into the A, and then you put in the A into the B, yes. And then you can go back and forth. And I think I've shown it. I mean, I think this is a bit dirty because you're just using a different value of true. I think I was also complaining about that before, that -1 also corresponds to true, you know, in C++. And apparently only 0 is false. And then the other thing, the rig doesn't even hold anymore for multiplication if you use a different value then. Yeah, because like you're breaking that law, right? Okay, well. No, I think that we've done it. Now I need to actually make the presentation. What do we even have? Right, we also need to solve those things maybe. What's on ADTs? Code. What am I even doing? It doesn't even show that you can make bigger structures. I have a friend in mathematics. He's PhD in category theory. I remember him saying that like one of the most recent topics in modern math. Yeah, I think it's a new development indeed. They're using it to go from one mathematics branch to another. Like it's like a bridge, I think, between subjects. But like this guy is actually using it as a way to explain programming, or well, basically tying it to programming to make it easier to understand for programmers. That's why we're reading his stuff, because he's like, you know, has the target audience of programmers. And then, you know, he ends up with Haskell because Haskell happens to be really good at explaining category stuff. And then because we're programmers, we also know C++. All programmers do. And he is aware that we don't always know Haskell, so he has the C++ examples as well. You get these kind of beauties in there. You know, are you familiar with C++ subness? Subness, right? Yeah. I think C++ has become pretty rare these days. I used to do C++ at Microsoft. What does it fucking do? Cannot assign value, right? Can't be final, huh? Main method not found. Let's actually try executing this then. So I found main. Tuples everywhere. Tuples. Static. You know what? I want to show something. In Java you have this construct, static blocks. And you can basically write code in here. This will be run on initialization of the program. It's void. I think you need to have a main, otherwise it doesn't want to compile. You could run that. Main method not found in the class. Oh, it needs to have string args as well, right? Look like static. Alright, you need to be static. This is really hard to write. Yeah, so the DTD gets executed on class loading, and then the YYY gets executed. So, you know, if you want to write a Java program, you can just do everything on class loading. That's fine. So we'll write it in here. Tuple int string d is new tuple for. Hey, what's up, Raphael? We just do some casual Java programming. I'm making a presentation about algebraic data structures, but these guys, they don't really know, any Haskell, so I need to make it accessible, I think. And right now I'm just testing out if this program actually works before I put it in my presentation. What's your favorite language? Good question. You don't know about ints? My favorite language. And this works apparently. Yes, like, I think by far I wrote most stuff in Haskell, but I don't know if I would call it favorite. What's your favorite language, Raphael? Raphael? I was inclined to say I just hate them all, like Soding does. It's much easier to say that. Love them all equally. I think it works. We learned that we need to make a constructor, otherwise it doesn't work. But how did we even do that? Did they close it? No. Okay, so we have tuples, right? We did it in Java. Oh, this is by the way, look, this entire thing. We need to export it to... Oh, okay. I remember now. We need to actually load... We need to put Emacs into... We need to convince Emacs that it actually can export into presentations as well from org mode. And to do that, I should probably at some point set this up properly, but I'll never do that because I don't make that many more presentations these days. But in my old configurations, I have like some magic. Some magic to make Emacs export to HTML and JavaScript. Yeah, so we can actually make out of org documents beautiful presentations with the help of no. This is, by the way, a literate Emacs configuration that explains everything. I stepped away from this because I just like the only thing I ended up doing was adding headings, and that's about it. But what we need to do is we need to add support for org export or something. Export reveal, I think it's called. Reveal.js. I even used Emacs for JavaScript development. Wow, must have been long ago. I don't think Reveal's anymore around. I asked you, man, what is your language of choice? That's a different question. Like, what's your favorite language of like what would you use for new projects? And at the moment, I'm usually settling on Haskell, but it doesn't really make it my favorite though. Like, I'm really eager to explore more Clojure, and I really want to go into Idris at some point in my life, but that has to wait. Yeah. So where was this? I think I just need to add it the old-fashioned way. Reveal, huh? Emacs reveal.js. Not. Exhaust. Don't they just have this? Export as HTML. Export to LaTeX or to plain text. Publish. I don't even need to do this. I can just do this, and I'll just get Pandoc. I'll just get Pandoc. It's being installed. It's just being installed like that, without having to reboot Emacs. Now let's just throw it through it and see what we got out. Download the latest reveal.js and place it in a folder called reveal.js. No. Oh, it's even shorter. Oh, it's not. It's like the entire URL's in there. It seems acceptable actually. We'll just use reveal.js as a... And then we'll also... Oh, they're actually putting in Pandoc. This is it! This is the magic I wanted. We can have reproducible build. We can have reproducible presentation. How about that? And then I don't need to do this anymore. Oh, that's so nice. No, not Twitch. What am I talking about? Ah, that works. Cool. I guess we can update you. Are you absolute? No, not master. I don't want to have master. I want to have latest. Okay. Now we need to do reveal, huh? Arc reveal. No, just reveal JS. Proficient 3.8. Oh, he has tag. Oh, excellent. That's really nice. Can you just use that? In pandoc reveal JS. Oh, out. And the input file will be category.org. And now we can just build that. Presentation.nix. Now I have a reproducible reveal.js. I guess. Yes, okay. Wanted that. Got that. Excellent. I like the new aligning. It's a lot clearer now to see if what's going wrong. Like before it just did everything in line, but now it's readable. Must be a new feature of Nix. It's called Ruby Talk. It is called Ruby Talk, huh? ADT Talk. Tuples. It works. Can I like give options to pandoc? I don't think I can go down. It just puts everything like this below each other. Then again, it's probably not a good idea to do that. Guess I can do either as well. Okay, cool. Now it should get a nice presentation out. Just close that, I guess. You can represent a lot of things as tuples. The fuck's alpha? I think I skipped this part. A to B, C is A, B, C. Let's just swap. This is the same thing as swap. Why would you define this function? So it's an isomorphism. It's just the same way of repackaging data. So this also makes you say that these tuples are actually sets, because we don't actually care about the position of the items inside them. That's what you also kind of derive from the isomorphism stuff, I think. Huh. You can interpret the creation of a product type as a binary operation on types. Yeah. Live with isomorphism. Okay, so we did nesting. I should have my own examples as well. Getters and setters. What is it? Let's not do... Okay, let's build this. See what this does. I want to like see if it fits. It's my main concern. Epic tuples is a string int. Then we have this epic swap function, and then it still be epic. You can also do it in Java like that. And then we have the nesting stuff, right? You know, casual nesting stuff. Right. We also need to talk about monoids for sure. Oh, I closed the other one right again. I need to also talk about the alpha. This is the same as swap. ABC. No, it's not. It's actually moving out the X, grouping the Y and Z. Like the fun thing about tuples is that you don't even need to define a... You don't need to do a term level thing because there's only one way you can implement this. This function is invertible. You can interpret the creation of the product type as a binary operations on types. From that perspective, it was, looks like a monoid. Right, the entire narrative of monoid, I didn't capture that at all. It's kind of important to solve the exercise as well. Like you need to realize that this group is a this category is a monoid. So yeah. What language is it even? You got like associativity, mutating debug information to make stacked overlays use position. Relative, you can optimize Java to start Emacs from a Nix shell sometimes though. What? Associativity there. And then, you know, we can say mempty is unit. And we can say mapend is this. AB instance monoid. Okay. There's more general way to find the product and type in Haskell, especially as we will see soon when they're combined to some types. Uses named constructors with multiple arguments. Pair, for instance. Saying the set category of sets is mono the category. There is a more general way of defining product types in Haskell, especially as we see soon when they are combined with some types. Uses named constructors with multiple arguments. Pair, blah blah blah. Here, pair is. Oh, you're making pair, huh? I think we made before. Guess we can like call this thing pair. Hence why you need a lot of difficult hacking. I don't for the awesome like for the template stuff. It's fine, right? Like I have a. So we have reproducible builds today. Map. We have reproducible type presentation. Oh, I have it here. Meets. Oh, in Elm. Yeah, they don't like applicative. Well, to be fair, we also have in Haskell lift A2, right? We need type classes. You don't understand. Like if you leave that stuff out, it doesn't. It's basically gatekeeping for people who like that stuff. So for reusability, yeah, they don't like code reuse. That's just it. But now they don't have to worry about it either. By the way, type classes get desugared. You know, they get desugared into records. I am saying to you guys, type classes don't exist. It's just records. It's records all the way down. In fact, you can do all the type class magic which you want to do in Haskell, also in Elm. You just need to write records instead. So we have tuples, epic tuples, string int, and then we can swap, and then you know it's swapped. It's not that advanced stuff, right? And then you put in the x, y. Okay, cool. Then we also can nest this stuff, and we have, you know, we can pull out the a from the argument and put it into the second part. This is probably how I'm gonna present it as well. To think of it, I need to get a good story out as well. I need to say the words. Say the words for presentation. What would I say about this? Yeah, that's also like alpha. Alpha's pretty cool. You can, you know, swap things around differently. And you can also go the other way around, and that means it's also an isomorphism. In other words, it's a monoid because we have associativity. And the other thing, of course, we need to fix mempty, right? Right, that's what we're leading at, right? So we started with tuples. We just like, okay, this is a tuple. We can put some, you know, strings in it and some int in it, and we can swap them around. And that means that they're like equal to each other up to isomorphism, right? Click. Next slide. We have the alpha function, which means that we can, you know, put out values from one side and put them into the other side. But we can also do the opposite of this alpha function, meaning it's still an isomorphism. In other words, we have associativity on tuples. In other words, it's a fucking monoid. God. It's a monoid! The door! Enterprise. Needs more. Yes, we even have that! Look at that! It's empty. Let's use the type signature and see if that helps. Done for. No, this is not my plan. What am I talking about? Monoid A to A? Oh, that's like a monoid under endomorphisms, right? What are you talking about? It's kind of cool, I know these words. Why are you upset? Why? Why no like? Why code not work? Why does 3 not grow? I wonder if Why? I need to have another color scheme, I think. But we can fix that, I think, as well. Where is it? So we have our reproducible presentation build. Yes, presentation.nix. Very important. Can I have like options for reveal.js? Unlock. Yes! I wanna have like blot. V team. Blot. I wanna see the blot. I wanna see the blot. Ah! I like the red color, but I wanna have this color change. How do I change the color of code? Bug, why code not work? Syntax highlighting. You're doing that. You can add no highlight. But I want to have highlight. I just don't want to have it blue. I can't read this. Can you read this? Change color or something to teal or magenta. I'm looking at that. Yes, thank you. I'm trying to do that. I just don't know how. I need to convince Pandoc as well to do this. Even if I could find it in here, I still need to convince Pandoc. Magenta. We should have Molokai. Where am I? What am I doing? I'm hoping you guys don't get a epileptic shock because of I'm switching too often with screens. I say that and then I start switching again. What the hell? Let's move this to 9 maybe. Actually, let's make you small. People, yeah. Do you know of people comparing RAM speed impact on AMD versus Intel? Doesn't GTJS run transactions eventually consistent server side or optimistically client side? Run in transactions eventually consistent server side or optimistically client side? Whoa! Okay. Algebraic data types. I want to have a subtitle as well. Can I do that, by the way? Category. 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 Corky. It's a rig. Yeah. My shuttle doesn't. Why? Oh, we can. Category. Merge art. Okay, let's open the dope again. Category small brain. I'm gonna forget this. Gonna play some Warfork. See you later, man. See you later. Oh, by the way, I forgot to mention, but that stream of tomorrow I can't do because I need to go to this meetup. So it will be postponed till to Tuesday. I'll do a stream on Tuesday. A replacement stream. Epic replacement stream. Yeah. But see you later, man. It's okay. It's okay. It's okay. Right. There we go. We'll just say AutoK. Oh, I don't like the font. Why do I have a crappy font for this? I need to install Korean fonts, I think. Font Nixos. Might be worth disabling font config premium. Okay, let's not get distracted. We'll just have a crappy font for that, it's fine. What I wanted to add here, I forgot. I wanted to do like 4 programmers. Algebraic data types for programmers. Category theory. I want to have an image as well. I want to have Hisoka. Can I add images? I bet I have so many spell errors. Tuples. Tuples. One void. Okay. Then we go to pair. We do fist and set first. And then we go to records and generate that stuff. And then either we'll do a bit of Scala. Oh my god. Challenges. It's not everything. We forgot the semi-group stuff. The ring. The lattice. Yeah, that's important. Are you gonna explain the categorical perspective? Yes, I should be doing that. That's what I want to do. We forgot the void stuff as well. It's important, I think, for error. Like I'm just following this blog post, right? This has like the should be explaining the categorical perspective. The issue is like I just don't. The post is pretty nice, okay. I need to add this as a chapter as well, for sure. I just did either now. That's not enough. We need to do algebra as well. So that's like algebra of types. The thing is that addition and multiplication is distributive property. So you have distributive. Begin. But the entire goal of this presentation is to explain this blog post, basically. So I'm hoping I'm capturing that, yes. And you know, we'll just copy and paste this in. Because like, the equal signs become arrows. If you can go both ways, no they're not, that's just it. If you go both ways, then it's equal. If you can do prod to sum and sum to prod, then you're equal. Up to isomorphism at least. I don't know if this fits, so I'll check it again. No, algebra. A times B plus C is equal to A times B plus A times C. That's like, this is distributive, right? This is the distributive property. Distributive property. Yeah. And then the other property is under annihilation, which is actually something that blew my mind. Oh, we skipped that maybe. What's the void stuff? Annihilation. And then can make question mark. Yeah. It's a lot of effort. Actually, it's unfortunate because I lost a fair bit of songs when I switched, like when Dubtrack died. But yeah, what do you do? Are they still dead? Yeah, they're still dead. Let's see how far you can stretch this analogy. For instance, does multiplication by 0 give 0? In other words, is a product type with one component being void isomorphic to void? Can you make this? In other words, is this an ISO? Is it an ISO? Tell me, guys. What do you think? Can you make a tuple with an int inside? Without using bottom type, by the way. It's not allowed. Bottom type doesn't exist. To create a pair, you need 2 values. Although you can easily come up with an integer, there's no value of type void. Therefore, for any type... Yeah, okay, he's explaining it. Another thing that links to addition and multiplication is the distributive property. You don't call it annihilation, huh? A to 0 is void. Yeah, we need to add this as well. Actually, we added in the title to like, you know, make it obvious what we're talking about. I think it's pretty obvious. Like, if you hear the word annihilation and you see a times 0 is equal to 0, that's, you know, it's a strong connotation with each other. I mean, I still remember that word annihilation from one blog post I read about doing that kind of stuff a long time ago. Another thing that links in addition to multiplication is a distributive property, right? So we copied all over that, like most of the code, I think, a fair bit. Right, and now we need to talk about rings. Rick, we need to talk about Rick. So actually, what I don't like is that he just says it's a Rick, even though he could have asked like, oh, try to do subtraction with this stuff. How do you do subtraction with types? Tell me. Well, you use type families. Haha. That's how you do subtraction with types. I can do it with kinds. Semi-ring. Just a pun ring without an N. But bearing that, you can get mileage from the translating the statements about say. So it's called a semi-ring. It's not a full ring because that's why we have. What are the properties of semi-ring again? Semi-ring. Like we have the distributive thing and we have the multiplication thing, right? A set R plus commutative monoid with identity L0. This is important. Dot. Monoid with identity L1. Multiplication distributes over addition. Which is this thing. And then the final thing is annihilate! Yes! I saw it! Multiplication by 0 annihilates R. Told you, Zuck, it was annihilation. You told me that was annihilation, but I like to believe I know things. Okay. And then we can have a translation table. Table numbers. Just put that in. Put it in. Numbers. Types. 0, void, 1, unit. A plus B. Either A, B is left. A or right. B. A times B. A2 is equal 1 plus 1 is equal to true or false. What does that mean? I just realized I added a dash there. Now everything's fucked. No! Can't escape. I should do either AB, it's fine. Doesn't fit otherwise. And I can't make it work. Okay, fix that. Excellent. So, either value is either a left or a right, right? I also made like a Scala implementation for it. And here you can see it very explicit, right? You wanna set some field DDD, and you'll have it give it some value on the left side with A, and on the right side you'll give it with B. It's pretty simple. And in Scala we need to hack inheritance to make this work, because we don't have native support for some reason in Scala for doing either. Right, and either is also a monoid. Again, like this is a really important property to have. Like, this is like the basis. This is the basics. And void will be the neutral element, and either is the binary operation. So, what I mean to say by this statement is that if we attach an either a void, like if you have a type either a void, it's basically the same as a. Because the void cannot be inhabited in Haskell. So like you cannot create this value. You cannot create a value of type void. So if you have an either a void, it's the same as a. It's isomorphic to a. It's not the same, but it's isomorphic to say a. It's like kind of the same. It's the same in terms of category theory, I suppose. And now we'll introduce the next part of the block post, which is the analogy part. Which we do for addition and multiplication, right? So what we do here is we try to make our types be numbers. So we can say, for example, that unit has a value of 1 and void has a value of 0. And if you draw this analogy, how far can we get? That's what we're trying to get here. So first of all, is the annihilation property still available? Annihilation. Maybe if we do full screen. Oh my god, it's too big. Annihilation. Meaning annihilation and the multiplication, right? Okay, if we equate these types to numbers, do we get like annihilation? In other words, can we if we multiply something with 0, do we get 0 out? In other words, do we get void out? Because void was 0, right? So let us ask ourselves, can we construct a value of int void? So a tuple of int and void. Can we do this? Can we do this, guys? Come on, tell me. Can we do this? Come on, chat. You're sleeping. Is it true that there is an isomorphism between void and any tuple that contains a void? Okay, so like, you know, if you want to make the first value int, can you do that? Can you create an int? Yes, you can just give it 5, right? Okay, how do you make a void? Tell me. You know, we can't. It's impossible. So yes, this property holds. And now the next one is a distributive property. And this one is a bit more complicated to explain because it involves math. So if we multiply a to parenthesis b, c, we'll get this result a times b plus a times c, right? How do we do this stuff in Haskell? Well, you know, we do a bunch of pattern matching. But it is possible. So this property also holds by just having the implementation there. You can see that. It was basically, in the blog post itself, it was written as, you know, trust me, it's true. Even though it wasn't proved. Then we get to the rig. Rig is a semi-ring. Rig is basically a semi-ring. And a semi-ring is equal to a ring without an end. Ha! It's a rig. Get it? So we ask ourselves, is the rig a commutative monoid with identity L0? We're talking about types now, right? That's R. Is it a commutative monoid with L0 for addition? So are our sums a commutative monoid? And if we go back, monoid either, right? It's commutative. Is it? Is a monoid with identity L1. Multiplication distributes over addition, we just saw this. And multiply by 0 annihilates R. So yeah, we have a rig. Our type system is a rig. Hooray! And now the translation table numbers. So now we can like line up numbers with their types equivalents. We basically get into the algebra stuff, right? So 0 was void and 1 is unit. If we have a plus b, how do you put it in types? You do either a, b. A times b, how would you represent it? That's a comma b. And 2 plus 1 is data bool or false. And you can do 1 plus a as well. The final thing I want to put in is, I think I put in a lot. And then logic, right? False, true, or and. And then we get to like Curry Howard. Yeah, we're not gonna mention that, I think. Then challenges. Okay, cool. I think I got everything, guys. I think I got everything. Actually, like right on time. Oh, it took me a long time to finish this. I thought we would have extra time to do other stuff as well, but there you have it. And